Hey guys, so basically in today's GFG POTD, we have a problem, merge two sorted linked list. So basically it is a medium level problem, and as the problem statement is given here, given the head of two sorted linked lists consisting of nodes respectively, the task is to merge both lists and returns the head of the sorted merged list. So basically in the given problem, we have two sorted lists and our task is to merge it. Okay, like for example, in the example one here, we have head one, which is having a list like 5, 10, 15, and 40, and the head two consists of elements like 2, 3, and 20. And after merging it and sorting it, we are actually getting the output as 2, 3, 5, 10, 15, 20, and 40. So here we have to do simply what? Here we have to simply perform merging operations and sorting operations. Okay. So how we can do these things? In such a way we can get a single complete linked list with having sorted and merged lists. Okay. So this is an example first and this is example second. Here we have elements like 1, 1, 2, 4. So after merging and sorting, we're actually getting these elements as an output. Okay. So basically this question is like asked in multiple companies like Zoho, Flipkart, Equalite, Amazon, Microsoft, Samsung, Exet, MakeMyTrip, Oracle, Brocade, Synopsys, Coit systems, Bedsavar. Okay, and it is completely based on topics like linked list and data structures. Okay, and we need to solve this problem with an expected time complexity of order of n plus m and expected space of order of 1. That means we don't have to use any extra spaces here. Okay, so before solving this problem, first of all, I would like to explain about the concept. So let's understand it. So yeah, this is the basic example one here, which is having the elements like we can select 5, 10, 15, and 40, or we can select values like 5, 10, 15, and 40. So basically this is our list first and this is our list second, 2, 3, and 20. So first of all, for solving this problem, first of all, I'd like to explain it all about my brute force approach here. So if I'm talking about the brute force approach here, let's say what will be the brute force approach, how we can solve this particular thing. So first of all, by analyzing this linked list, by linking this to both of the linked list, we can say first of all, by for solving this in the brute force approach, we can create our new array, okay, of size n plus m, right, to store all those elements of like linked list first and linked list second. So for that we have to get a new array of size n plus m so that we can store all of the elements or the values inside the new array, right? And after storing all the values, that means after merging all the values in the new array of size n plus m, we need to what? We need to perform sorting. We need to perform sorting. Okay. Then after sorting it, we are actually getting our output as array. So we need to perform it into linked list. So we have to convert array to linked list. Okay. So here we have to perform three things. First of all, we have to create a new array. Then after that, sorting. Then after that, we have to get our array into the linked list. So if I'm going to check about the time complexity, space complexity for the brute force approach. So here we can say that for creating our time complexity. So for creating a new array, the time complexity will be like order of n plus m. Okay, order of n plus m. Then after that, here we are actually performing sorting algorithm on both of the linked lists. So here we are actually getting sorting as like m plus n log n plus n log n. In this space, here we also like using the spaces of order of n plus m, right? Here we actually, this is basically I'm talking about time complexity, and here we actually like also converting our linked list to linked list, converting our array to linked list also here. So here the time complexity is like getting too much as it is like required. Okay, so here we can like getting like conditions like we can say that extra time complexity here we can get the one like time limit exceed or space complexity. Talking about space complexity, so maybe here we are actually getting order of n plus m as we are like using extra spaces. Here we are actually creating a new array. Then after we are storing all those values of linked list. So here we are actually getting the space complexity of order of n plus m. So basically this is a brute force approach. No, for solving this particular problem by using linked list with having the time complexity of order of we can say that for the time for order of n plus m and space complexity of order of 1. So for solving this problem, what we can do here. Okay, so basically the approach is very simple. First of all, what we have to do, as we have like given the question, like we have our head node, okay, which basically points to this. Okay, so this is basically our head node, right? Head node 1, and this is basically our head node 2, right? Now what we have to do here, we are actually going to create. First of all, we have to point this is our head node and head 2. So let me point this thing. So node star. First of all, we have to define our point p1, which is equal to head node first. Okay, head 1, and then after that, here we have to create our node star p2. Okay, which is basically our head 2. Okay, now created here point 1 and point 2. Okay, here we can see that here we have created our point 1 and point 2. This is basically our head node second, right? Point 2, and basically this is my point 1. Okay, now what we have to do here, we have to perform simple operation here. Okay, now we are actually getting point 1 and point 2 as our node. Now what we are actually going to perform here, first of all, for solving this problem, okay, we need to do first what here we have to merging. Here we have to perform merge operations. So before for merging operations, here we are actually going to create a new node which is basically pointing to at this position. Okay, let me show here. So let me first of all have to create our new node which is basically pointing initially to the first node with the value we can select -1. Okay, and I have to point this node as our head node. Okay, so let me write this thing. So I define this node as a head node. Now this is our first node which is basically pointing to our head node, and I have like given this node value as -1. Now we need to compare these values. Okay, The approach is now simple now here. Here we have to do what? Here we have to do comparisons between these two linked lists, and then after that, those value which is having lesser value, then we need to write first it there, then after that, the second element in such a way it will be sorted manner, right? With the help of this pointer node, head pointer node. Okay, so basically this is the node which basically we turn our node with the time complexity of order of n plus m, and with having the same space, we need to create this linked list into a single linked list. So let me create here. So first of all, I'm going to create a node star temp. Let me check here. Temp is equal to, we have to create our new node with value -1, and then after that, what we have to do, we have to create our new node start head is equal to, which basically pointing to our temp node. Now once we have like created all those things, here we have to do traversal. Okay, so node while p1 is not empty and p2 is not empty. Now we have to do what? Here we need to check the condition that which value is like lesser. In such a way we can merge the linked list in a sorted manner. Okay, so if p1's data is like less than or equal to p2's data, then where we have to store, we have to store inside the temp. Okay, which we actually initially pointing to our this node, that means -1. Okay, so here we have to like create our node here. Okay, so let me write this thing. So in the initially we actually getting -1, then after we actually comparing between these two lists. Okay, so first of all we are going to compare this thing. So is p1 is like less than p2? Here actually no. So here what we have to do, if p1 is like less than p2 data, then we have to do what? Here we have to store like temps next is equal to, we have to store p1 value. If my p1 value is like less than p2 values, then after that we have to do what? P1 is equal to p1's next. That means after having after getting the value, we need to check it for the next value. Okay, then after that, and if it is like p1's value is like not less than p2's value, then we have to perform the opposite operation. That means here we have to store temps next. Here we have to store the value of p2 inside the temps next, and then after that, here we have to move our p2s to the next node. Okay, after performing all those things, here we have to also like increment our temps node also. So temp is equal to temps next also here to perform. Okay, now after performing these things, here we have to return our head node. Return head node. Let's try to compile one. So here we are actually getting okay, node star p1 is equal to head 1, new node -1, and is equal to temp, while p1 and p2, if p1's data is less than p2's data, and I'm getting an error expected as okay, so somewhere I like put it comma. Okay, so here it is. Okay, let me again compile and run. Okay, so here I'm getting an error. The reason behind this is that we don't require this -1, and we are actually not getting 40. That means the last value. So we are actually starting our linked list with -1, as it is also like written here. I have also written a -1. Then after that, after comparing this value, I'm getting a value like 2. Then once I'm getting 2, then after that we have to like increment our p2. That means here we will get p2. Then it will compare 3 by 3 and 5. Then again we actually getting 3 as lesser than 5. So here we have to write here 3. Then again we have to like increment our p2 and move it to 20. Then after comparing 20 and 5, then here we are actually getting 5 here. So here first of all we have to write our 5. Then after that we have to increment our p1. Okay, so like that. So similarly, after doing this operations, we are actually getting 5, 10, 15, 20, and 40. So this is the output we are actually getting here. As we can see, output difference here we want 2, 3, 5, 10, 15, 20, and 40, but here we are actually getting -1 and 40. We are not getting actually here. So here we have to remove this thing as we have also started. So here we have to do what? Here we have to return heads next value, and we are not getting this 40 value. So for that, what we have to do? Here we have to write the codes for those elements which has not been covered. So for that, here we have to also perform the same thing. While p1 is not empty, okay, then we have to perform the same code. That means temp is equal to temps next. Then here we have to store temps next is equal to, here we have to store the p1 value which are remaining. Okay, and then after that, here we have to check it for p1 is equal to p1's next. Okay, if this element, then it is okay, but if there's an element, then it will move forward and check it for another element. So here we have to do temp is equal to temps next. Similarly, for we have to also perform it for p2 node also. So p2, we have to perform temp next is equal to, here we can select p2. If p2 is like a remaining element, then we have to also perform for p2. p2 is equal to p2's next. If there's an element, then we have to also check it for p2. Then here we can simply move our temp node, so temps next. So this is basically all the codes here for performing this uh, merging of these two sorted linked lists. So in the game plan, first of all, we have like traversing inside p1 and p2 until p1 and p2 is not going to be end or empty. We have to compare the values between p1 and p2, and those which is like having lesser value, we need to take inside the temp variable, and then after that we have to increment those value. Or if it is like not lesser, then we have to check it for those elements, and then after that we have to perform same thing. Okay, then after that we have to like write our codes which for those elements which are like remaining in the list. So for P1 I have written this thing, and for P2 this thing, and then after that I have returned our head node with our next node. That means we don't require this thing, so we have to remove this thing, and remaining all those elements like 2 3 5 10 15 and 40 we require this thing, so we actually getting these things. Now I have done this one with an expected time complexity of order of n%, and this is complexity of order of 1. That means I don't have to use any extra space. Let's try to compile it. So here our compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.